Welcome back. Today we're going to look at solving more exponential equations, but today we're going to notice that we don't have that 2-to-1 ratio for our exponents. Remember, when we solve a quadratic or a similar form of a quadratic, we look at those exponents and we look to see that we have that 2-to-1 ratio. So if we multiply the middle term's exponent by 2, we'll end up with that first exponent. In today's problems, we're going to see that we have the common base, but we don't have that 2-to-1 ratio. So in this case, if I take x plus 2 and I multiply it by 2, I would get 2x plus 4. Well, that's not going to give me my 2x plus 5. So the first thing I'm going to do is I'm going to work to get to that 2-to-1 ratio. And notice what I have to do to be able to get to that 2-to-1 ratio. I'm at 2x plus 4. I have 2x plus 5. So I'm pretty close to what I want. I just got to get this 5 down to a 4. And the way I can do that is think about my exponent rules and where this 2x plus 5 comes from. If I think about this base, this 3 to the 2x plus 5, I can think of it as 3 to the 2x times 3 to the 5th. In that manner, because when we multiply common bases, we add the exponents. So 2x plus 5 will give me that 2x plus 5, my common base of 3. So I can break this apart in this manner, or in any manner that would keep it as 2x plus 5. So I could also break it up into maybe 3 to the 2x plus 4, which is what I want, times 3 to the first. Again, as long as these exponents add together to give me what I have, it's going to work out for me. So I can rewrite this as 3 times 3 to the 2x plus 4 minus 10 times 3 to the x plus 2 plus 8 gives me 0. Now I have that 2-to-1 ratio. And now I can come off to the side and do my substitution as I did before. So here I'm going to let y equal 3 to the x plus 2, and y squared is going to equal 3 to the 2x plus 4. So I have now my 3, which I brought out before, y squared minus 10y plus 8 will equal 0. I can go ahead and factor that. Hopefully it factors for us. I think it will. We can do, 4 and 2. We can do, what? Oh, no. Sorry, it's going to be a 2 and a 4. There we go. And they're both going to be negative to get us a positive 8. So now I can go ahead and solve this equation. I have 3y minus 4, so 3y minus 4 equals 0, and y minus 2 will equal 0. I can go ahead and solve for y. So y will equal 4/3. In this case, y will equal 2. And now comes the fun part. I can replace my y with 3 to the x plus 2. Well, notice 3 to the x plus 2 and 4/3, I don't have a common denominator or common base, nor do I have it in 3 to the x plus 2 and 2. So what I'm going to have to do is come up with, you guessed it, logs. So using my calculator off to the side there, I'm going to take the log of both sides. I have x plus 2 log of 3 equals the log of 4/3. And here I'm going to have x plus 2 log 3 is going to equal the log of 2. And now I can go ahead and solve for x. So I can divide by the log of 3. So x plus 2 will equal the log of 4/3 divided by the log of 3. And I can subtract my 2 over. We're just going to subtract the 2 over there to get my x value. In this case, x is going to equal the log of 4/3 divided by the log of 3 minus 2. In my calculator, it's kind of dark to see there, but in my calculator I'm going to hit log of 4/3, so 4 divided by 3, and my parentheses, divided by the log of 3, again, and my parentheses, and then minus 2. And that's going to give me negative 1.738. I'm going to do the same thing over here on this equation. I'm going to divide by the log of 3 and then subtract 2. So x will equal the log of 2 divided by the log of 3 minus 2. Again, we use my calculator. I'm we have a log of 2 divided by the log of 3. You can make sure that you end your parentheses for those logs, and then minus 2. And that's going to give me negative 1.369 as my answer. And that's going to give us an example of something where we don't have that 2-to-1 ratio, but we can make a 2-to-1 ratio. Alright, so they're not going to get a whole lot more complicated than that as we get through these, but I'm going to go through a couple more examples, just kind of play around with them. Notice this one we're equal to 3, so we want to get rid of that equal to 3. And to do that, we're going to subtract 3 from both sides. So we get it equal to 0. Now I look at that 2-to-1 ratio. If I multiply 2x by 2, I get 4x. I want 4x plus 1, so I'm very close again. If I break this apart into 2 to the first times 2 to the 4x, minus 5 times 2 to the 2x minus 3 equals 0. Now I have a common base with that 2-to-1 ratio. So I can come off to the side and let y equal 2 to the 2x, and y squared then would equal 2 to the 4x. So I have 2y squared minus 5y minus 3 equal to 0. And go ahead and factor this. We get 2y and we get y minus 3 and plus 1. I can go ahead and set each of these parts equal to 0. So 2y plus 1 will equal 0. Y minus 3 will equal 0. Subtract my 1, divide by 2, so y equals negative 1/2. Here, if I add 3 over, I get y equals 3. Replacing my y with 2 to the 2x equals negative 1/2, and 2 to the 2x equals 3. Notice here, we have an exponential equation, but that exponential portion is equal to a negative value. Remember, an exponential can never equal a negative value. So we get rid of that. Over here, we have, again, the bases are different, so we can take the log of both sides. It allows us to bring that exponent to the front. So we have x, or 2x, log 2 equals log of 3. I'm going to divide by the log of 2, and then divide by 2 as well, so or 2 logs of 2. So in my calculator, again, I'm going to pull that off to the side here. And I'm going to try to get as much in there as I can so you can see it. Let's say we have log of 3. We're going to end our parentheses. We're going to divide it by, and here we're dividing it by two things, so we need to make sure that we put it in parentheses. So we have 2 log of 2, and we can end those parentheses. And we get x equal to 0.792. Here's another one, and we're not equal to 0, so we can go ahead and make that equal to 0. We have 10 times 3 to the 2x plus 4, minus 3 to the x plus 4, plus 2 equal to 0. Now if I notice this one, if I multiply x plus 4 by 2, I get 2x plus 8. Well, that's going to be an issue because here I have 2x plus 4. I can't increase this. All I can do is take things away from it and multiply it to my coefficient. So we may have to, instead of decreasing the first term, we may have to decrease the second exponent. So we may have to come over here to the first one and take 2x plus 4. If I take 2x plus 4 and divide it by 2, I get x plus 2, don't I? So I can make this x plus 4 into 3 squared times 3 to the x plus 2. So that's what I'm going to go ahead and do with this one. So the problem, or the thing that you may have to look at, is instead of working always with the first one, you may also have to work with the second one. And it will be the case where we have to work with both in order to get that 2-to-1 ratio. So now here I have 3 squared times 3 to the x plus 2. Again, these two exponents are going to add to give me that x plus 4, which I had. So I'm not changing the meaning of it, just the look of it. And I still now have that 2-to-1 ratio. So I can come off to the side and let y equal 3 to the x plus 2. And then y squared is going to equal 3 to the 2x plus 4. So my equation is going to be 10y squared minus 9y plus 2 equals 0. I'm going to go ahead and factor. I get 5y and 2y. I'm going to put my 2 over here with a minus and a minus 1 over here. So I'm going to get y equals 2/5 and y equals a 1/2. Again, y equals 3 to the x plus 2. So 3 to the x plus 2 is going to equal 2/5. And I'm going to come over here to the side, and 3 to the x plus 2 is going to equal my 1/2. Running out of a little bit of room, I'm going to take the log of both sides and bring my exponent to the front. So I have x plus 2 log of 3 equals the log of 2/5. Go ahead and divide by my 3 and subtract my 2. So x is going to equal the log of 2/5 divided by the log of 3 minus 2. Again, in my calculator, if I just going to have some glare on it, I guess. So here we have the log of 2/5, so 2 divided by 5, end your parentheses, divided by the log of 3, end your parentheses, minus 2. And that's going to give us negative 2.834. And on the other side here, I'm going to take the log of both sides. So I have x plus 2 times the log of 3 equals the log of 1/2. Again, I can divide by my log of 3 and then subtract 2. So x equals the log of 1/2 divided by the log of 3 minus 2. And in my calculator, I take the log of 1/2, end your parentheses, divided by the log of 3, again, end parentheses, minus 2. And that's going to give me x equals to negative 2.631. And those are going to be my two answers. And I have one more problem here, I think. Another example. So here I'm going to take my negative 6 times 7 to the 2 times x plus 1. I'm going to move this over to the other side so it's equal to 0. So 0 is going to equal 6 times 7 to the 2 times x plus 1 plus 7 to the x plus 2 plus 2. Now it's going to have the same base, but my exponents aren't exactly the same. And again, on this one, I'm going to take my x plus 2, I'm going to reduce that to x plus 1, so it's half as much as this. So 0 is going to equal 6 times 7 to the 2 times x plus 1, plus 7 to the first times 7 to the x plus 1. So off to the side, my y value is going to equal 7 to the x plus 1, and y squared is going to equal 7 to the 2x plus 2, or 2 times x plus 1, which is what we have. So we have 6y squared plus 7y plus 2. Go ahead and factor that. I'm going to break up my 6 into 3y and 2y. I'm going to have a 2 here and a 1 there, I believe. Yep, that gives me all that I want. So now I'm going to have 3y plus 2 is going to equal 0, and 2y plus 1 will equal 0. Subtract my 2 and divide by 3. Y is going to equal negative 2/3. And here, subtract 1, divide by 2, we get negative 1/2. Again, y is 7 to the x plus 1, an exponential, equal to 2/3, and 7 to the x plus 1 is going to equal a negative 1/2. Again, recall, if we have an exponential equation, that exponential portion can never equal a negative value. So here we get no values, and over here we get no values. So this equation has no solution. And there we have it. So there's several examples of being able to solve an equation that doesn't have that common 2-to-1 ratio. Good luck, enjoy. If you have questions, let me know.